All right, today's lesson is about intercepts and how to use them to interpret some things when it comes to real-world problems, and also how to use them to graph. So if we read this example, pause your video, take a second to read the example. All right, when we talk about the beginning of their ascent, we want to think about where are the miners. And it appears that they are 90 feet underground, which means the miners are going to be at 0, because it's 0 time, and negative 90 because we're 90 feet underground. Then when we talk about where will they be at the end of the ascent, well, the end of the ascent would be if they were at surface level, which would be a 0 height, and it says it takes them 3 minutes to get there. Okay, which is going to make that point 3, 0. Now, if you don't remember this from last year, or if you haven't ever learned this before, this point is my y-intercept. My point up here is called my x-intercept. So intercepts are just points on the x and y axis. Specifically, it's where lines or functions that we graph are going to intersect the x and y axis. And one thing that's nice about intercepts is instead of having to find multiple points to connect, intercepts allows me to use just 2 points to connect my graph and make a linear function. All right. Again, just as this is a reminder that because we're talking about time, this is a good example of something that should be continuous. Additionally, I want you to notice, because we're gonna talk about this in just one slide, I want you to notice that when you have a y-intercept, all right, so when we got this y-intercept, the x value is 0. So for y-intercepts, x equals 0, because you're only on the y-axis, you're not moving left or right at all. And alternatively, for the x-intercept, notice that the y value is 0, because you're not moving up or down at all, you are simply on the x-axis. All right, so here's our first example, pretty basic. They're asking us to find the x and y intercepts and then to use those to graph the linear equation. So because we've got 2 different things going on, we're going to have 2 cases. One where we're trying to find the x-intercept, and then one where we're trying to find the y. And if you pay attention and you had written this down, your x-intercept is where the y value is 0, because there's no y component there. So when I do that, I'm going to plug the value of 0 in for y. So I'm going to say 3x minus 2 times 0 equals 6. And remember, anything times 0 is just 0, which you should notice then that this whole term is just going to disappear. So I'm actually just going to have 3x equals 6. And then that's pretty simple to solve. Divide by 3, so x is 2. And we should always write our intercepts as ordered pairs. So I'm just going to list my x-intercept is 2, because that's what I got for x, and 0, because that's what I had plugged in for y. I'll do the same thing for the y-intercept, except for the y-intercept, I'll plug in 0 for the x value. So 3 times 0 minus 2y equals 6. All right, same concept as before. 3 times 0 is just 0. So this whole term is just going to really be negligible. So I'm going to have negative 2y equals 6. Divide by negative 2. So y is going to equal negative 3. And again, we'll do a good job of writing out the intercept as an ordered pair. So we've got 0 for the x, because that's what I plugged in, negative 3 for the y. And then because we're writing that, it reminds you that these should be 2 separate ordered pairs. So I've got my x-intercept, which is at 2, 0, and my y-intercept, which is at negative 3, 0. And because they're telling us to graph this with no specific context or no domain, I'm going to assume that it's continuous. So a domain of all real numbers, and I'll just go ahead and connect those with a straight line. Okay, we can also find x and y intercepts even if our equations are not written in standard form. Remember that f of x is similar to the variable y, so we could rewrite this to say y equals 4,500 minus 3x. minus 300x. Whoops. All right, and then we can use that. It's not as easy, but we can still use that to find our two intercepts. So I could find my x-intercept, which means I would plug 0 in for y, 4,500 minus 300x. Now this one is not as easy because now I have to move the variable over before I can divide, which is going to give me positive 300x equals 4,500, or x equals 15. Notice that they already plotted that point for me on the time. And then I could solve my y-intercept. This one's a little bit easier, so I've got y equals 4,500. Man, I'm struggling. 4,500 minus 300 times 0. That whole part's going to just be nothing. So that means y is equal to 4,500, which again, they have already plotted for me. But specifically this example, the part that you really need to see here is they want us to find and interpret the x and y intercepts. And you may have picked up already, but when you read this problem, when you look at the graph, the y-intercept is always going to be your starting value. And since most of these examples have to do with time, the x-intercept is going to be the end of the problem, or at least the point in which the function no longer makes sense for what the problem is considering. So think about your y is where you're starting, right? We're going to start, in this example, start at the top, and the x is where you're going to end. All right, the last thing I want to show you is that sometimes, and actually a lot of times, intercepts are not the best method for graphing something. So we have two examples here. First of all, in A, intercepts are not the best method. The x and the y are not on the same side of the equation, and generally anytime that happens, intercepts aren't as easy to work with. If it were me and I was trying to graph this, I would not use intercepts. Instead, I would try to isolate y. And to do that in this specific example, we're trying to get rid of 1/2, so I could multiply by 2. Now remember, that means you have to multiply every single thing, every single part by 2. So I can multiply this 3 by 2, and then the negative 3/4 by 2, which is going to give me, those cancel, y equals 6 minus, and remember with fractions you can multiply straight across, so you can get 6 over 4x. And we could even simplify that one step further to say y equals 6 minus 3 over 2x. And this, we're going to learn the best strategy tomorrow. So what I want you to really focus on today is when intercepts are not good and how to isolate y in that case, and we'll work more on what to do with it tomorrow. All right, this is one last example of when intercepts are probably not the best method. Y is so close to already being by itself, it makes more sense to just try to divide and get y by itself. So if I divide every single thing by 18, it's going to give me y equals 12 over 18 x plus 6. And then one more time, we could simplify 12 over 18. Both of those are going to be divisible by 6, so that's 2/3 x plus 6. And we're just going to leave it there. Even though the directions ask us to graph, we're just going to leave it there for today and talk about how to deal with that tomorrow.